Hello. This part of the project is called Agent Trainer, and the idea behind Agent Trainer is that it's a training tool that agents can use so that they can improve their responses when they are facing customers or when they are assisting customers. So agent training has a direct impact on customer service, and it's an automated training agent that agents can use so that they come up with better responses and better assistance to customers. So the idea behind agent training is that it's a standalone offline tool which prompts a set of greetings, and the agents are supposed to respond to these greetings in and adhere to some standard and customized patterns. So some of the greetings could be very simple, like it could be things like "Have a good day," or they could be more complex conversations. And the agent training tool has a set of you know uh, set agent greetings that the agents will need commonly, and agents will have to train their voices uh, by repeating these greetings, and the training tool will take the input from the agent and compare the agent greeting with the reference or standard pattern and give a score, and based on the score the agent can identify areas of improvements, or get more practice, and it's basically like some kind of game where where the trainer plays a set of utterances and greetings, and the agent is supposed to repeat them, and after every repetition the agent's response is scored with the reference. So this could be a useful tool if you want to train new agents, or if you want to train agents to specified accents or to specified speech patterns. And yeah, so this implementation is basically using Python. It's a standalone implementation. So it's a Python process that will be running on some machine, and the Python process will have a set of uh, predefined greetings or messages that the agent will have to repeat, and after listening to every message, the agent will repeat the message and get a score. So let's just go ahead and do that. So for the purpose of the demo, I just have one example, and we can add more examples. So that you say in this demo, uh, like I run the Python. So this is a list file which contains a set of training utterances, and in this case I just have one utterance that we'll all listen to. And so let's go ahead. So this just input any key, so you just hit return to continue.
Economists were encouraged by a 1.6% increase.
The economists were encouraged by 1.6% increase. So you see it's finished recording, and it's now doing a lot of analysis there, and you see let's just go with this output. Let's see what it has done actually. So it played the prompt, the standard prompt, and then it prompted the agent to respond, and the audio from the agent was recorded through the microphone, and then this audio was analyzed using some speech features, and these features were compared with the reference feature. So that this one here, we have focused on three features for this project. One is the pitch, so the pitch pattern, rather the way the pitch goes up and down in the agent's voice is compared with that of the reference voice. Then we have what is called the there should be one more. There should be yeah. There's something called LPC, which compares the spectral flow. So this compares the quality of the agent voice with that of the reference voice. And then we have what is called the volume level of the conversation. So if the agent voice is very flat compared to the reference, then the agent will get a low score. On the other hand, if the agent's voice has the same richness in same dynamic range as the reference voice, they get a high score. So in this case, you saw that I try to repeat the prompt, and these are my scores. Like pitch score is 1.65. The volume score was like 0.05. So I spoke in a much flatter voice compared to the reference, so I got a low score. And then we have the spectral score, which is again which basically measures the speech formants and the speech characteristics, and that also got a pretty low score. So this is one example of the agent trainer, and one example of an utterance that the agent trainer can use. And this I just played one file, but you could have a set of files, and it'll keep playing all the files one after the other and score the agent uh, on every utterance. And these numbers are, of course, are a bit. I mean, they're definitely not final. We need to sort of improve them. But I've made some simple sanity checks to make sure that they're not too bad. And one sanity check is to actually replay the utterance that was stored externally and compare that with the my score. And I think when I did that, we got much better scores for the pitch and for the volume score and for the spectral score. Again, I mean, I don't want to put it right now because I have not tested this extensively, but in a couple of examples, it seems to be working okay. So that's basically the summary of the agent trainer, and we could add many more new features here. Like I've just looked at the trajectory of the pitch of the agent and compared that with the reference, but I could look at the direction of the pitch, whether it goes up and down, for example. We could look at like we could look at other speech features called Kepstel coefficients. We could look at other parts of the spectrum. Then we could look at pauses. We could look at the length of the overall speech. If the agent speech is much shorter than the reference speech, then the agent has to slow down. On the other hand, if the agent speech is much longer than the reference speech, then he has to hurry up. So things like that. So this basically is a training tool that the agents can use in a completely automated way. All that needs to be done is to uh, give a set of predefined greetings or messages that the agent needs to learn. And this is also independent of language. It does not need a language model. So it could be, the prompts could be in English or French or German, anything. That's basically a summary of the agent trainer, and I think the future directions would be to sort of validate all these scores and make sure that they make sense over a large data set, add more features so that it becomes more robust, and improve the user interface. For example, one could also give hints to the agent to improve. Like uh, one could point to certain sections of the speech where the agent is completely off, completely different from the reference, and that information could also be provided to the agent. And all this is completely automated. And also these prompts could be played again and again, so that the agent will essentially learn the the way to speak just by repetition. And that's one of the best ways of learning how to speak, right? And that's how children learn, and that's how music is taught. So it's a pretty good automated tool for a training agent. So it's in general, it's not just for agents. It could be used for training voices. So it's a voice trainer, and it could also be used as a music trainer. In general, but since we are mainly interested in voice and speech, uh, I didn't really compare music files, but one could also compare two files, two pieces of audio played by different instruments, and that are trying to play the same notes, and then come up with scores. So that's basically the my summary, and I'm going to stop right now. Thank you for listening.